CO magnifier text-to-speech converter industrial automation using modern controls, monitoring. Data logging and development of training facility in college abstract, industrial automation. IA decreases the need for human sensory, human energy and cost. Nowadays, as per the industrial requirement, the highly growth in the sensors, control and automation technologies like control systems, i.e. Programmable Logic Controller, PLC, and Supervisory Control and Data Acquisition, SCADA, historians for data collections and easy analysis, reports generations, other development towards IIoT Industries 4.0 concepts and implementations. These are performing a most important role in the automation of industries and increasing the demand of this kind of knowledge. Engineers in the industries. The basic introduction and hands-on project facilities development in a college by using different types of softwares as well as hardware tools to get the brief idea. To the upcoming students. Keywords: PLC, HMI, energy meter, induction motor, VFD, IM starting. Method. Data logging and reporting. Introduction. Industrial automation involves usage of advanced control strategies like modern control hardware, cascade controls, devices like PLC, sensors and other instruments for sensing the control variables, and signal conditioning equipments to connect the signals to the control devices, drives, other smart significant final control devices. Standalone computing systems, communication systems, alarming, reporting, data logging and HMI systems. HMIs offers the facilities like displaying the information on computer screens in other displays, logging the results in the database, giving alarm signal, etc. It uses technologies like SCADA, supervisory control and data acquisition, and other visual-based technologies. As we have visited many industries and the electricity board, nearby the Pune, we understand that the complexities, flexibility, remote operations, data logging, monitoring, reporting, and easy-to handling of machines in the factories are the business in the more cost-effective manner with fast meet the market demands. The development in the electronics and computer sector, use of modern concept in the automation demand is increased. Hence, in the industries uses of smart instruments, automations, communications, are used to meet the diversified business demand in the global manufacturing. Setups are set up in the various locations, real-time and fast, authenticate data and the information is on demand. Similarly, demand of sophisticated and intelligent, fast grasping of this upcoming industrial automation knowledge engineers required in the industries. By this concept, we have discussed with Dr. Deepak Bankar and Professor Swapnil Namekar to develop and implement the modern industrial automation projects training setups for students in the colleges to get the knowledge and hands-on before going to the industries at the education's level. 2. Block diagram and systems. PLC means Programmable Logic Controllers. The PL-CARE used to control automated systems in industries. The PLC are one of the most advanced and simplest forms of control systems which are now replacing hardwired logic relays at a large scale. The PLC is heart of the system. In Project NextGen NG16 DLPLC used the ladder logic implemented in CodeSys software. In that, PLC 8 input and 8 output supports. The PLC was interfaced with HMI by using RS-232 protocol and energy meter by using -485 rupees protocol. B. HMI, a human-machine interface. HMI is A user interface that which is connected to a person to a machine and system device. The HMI is most commonly used in an industrial process. As per industrial settings, the HMIs can be used for visually display data, track production time, trends, and tags, monitor machine inputs and outputs, etc. In project, the XOR Make HMI was used and J Mobile Suit is the development software used. C. VFD. Always in the industry, need arises for controlling the speed of a three-phase induction motor. The motor drives are able to efficiently control motor speed and improve machine automation save energy. The drive is in its variable frequency drive. VFD series is designed to meet specific application as per requirement. A VFD can be used to vary speed, direction and other parameters of a three-phase induction motor. In Project YASAKWA Make VFD is used. The rating of VFD is 1.5 kilowatts. The VFD is used for control the speed of induction motor. D. Induction motor and its starting methods. The AC induction motor is widely used in applications requiring constant speed operation. The induction motor is cheaper and easier to maintain and compared to other alternatives. The induction motor is made up of the stator, stationary windings and the rotor. The stator consists of series of wire windings of very low resistance and it is permanently attached to the motor frame. The voltage in a current is applied to the stator winding terminals and a magnetic field is developed in the windings. The stator windings are arranged. The magnetic field appears to synchronously rotate electrically around the inside of the motor housing. The rotor having a number of thin bars, e.g., aluminum bar, and mounted in a laminated cylinder. The AL bars are arranged horizontally and parallel to the rotor shaft. At the ends of the rotor, the bars are connected together with a shorting ring. The rotor and stator are separated by an air gap which allows free rotation of the rotor. The magnetic field generated in the stator, it induces an EMF in the rotor bars. In turn, a current is produced in the rotor bars, shorting ring as well as another magnetic field are induced in the rotor with an opposite polarity of that in the stator. The magnetic field in revolving in the stator will produces torque which will pull on the field in the rotor and establish rotor rotation. A three-phase induction motor is self-starting motor, theoretically. Three-phase induction motors have a starting method not to provide a starting torque at the rotor due to the following reasons: reduce heavy starting currents and prevent motor from overheating in. Provide overload and no voltage protection. In project I have done the three ways to start the induction motor using PLC. Induction motor control using DAL starter. Induction motor control using VFD through analog output. Induction motor control using forward and reverse control. E. Energy meter. The Schneider Make energy meter is used for measurement of different parameters like voltage, current, power, etc. The EM6436H model is used. In this module the in build -485 rupees port is there which is communicated with PLC. Fig. 1. Block diagram of system. In Fig. 1. This model all the inputs are connected to PLC and the information will be sent to the PLC through it. The output devices are connected to the PLC outputs and driven from the input sensors and from PLC program. PLC outputs will give the command to frequency drive and drive will vary the frequency and the voltage to the induction motor. The speed will be vary from the drive. Energy meter is connected to the PLC through 458 rupees communication and the data parameter will be read by the PLC through this communications. HMI will be connected to the PLC and information will be display or the commands will be giving for the operations from it. The parameters like voltage, current, kW and kVA are read by the load manager, which is interfaced with the PLC. The PLC is interfaced with HMI. In the existing system, NextGen PLC is used. Also energy meter, CTs, is installed in panel and HMI screen is display on front of the panel. There are 3 parameter displays on HMI screen. These are SLD, parameter and setting. By clicking SLD, SLD will appear on screen. By clicking parameter tab, all parameter are display like voltage, current, power, etc. And by clicking setting tab, we can change the threshold value. Once the parameters for threshold are set, the CPU of PLC will continuously monitor the parameters, though the energy meters connected as input to PLC. Electrical drawing. The ePlan software is used for design the electrical drawing. In that we show the single line diagram of electrical components and show the VFD connections with mains. In Fig. 2, shows the single line diagram of VFD connections. And the PLC program is developed in CodeSys v2.3 software. In that program we did the ladder programming. In Fig. 6. Fig. 6. Ladder logic of conversion of real value to integer value shows ladder logic of conversion of real value data to integer data, while in Fig. 7 shows the HMI operations for start, stop the VFD. In Fig. 8 shows the logic of input-output testing, and in Fig. 9 shows the analog output scaling logic with speed vary command is used. Development of HMI program. HMI programming is done in J Mobile Suite software. In that we develop the screens for operations. In Fig. 10, the input-output status shows which helpful for fault diagnosis. In Fig. 11, the VFD operations and induction motor speed indicates. In Fig. 12, the energy meter parameters display on screen like voltage, current, power, power factor, frequency. Data logging and reporting. The data logging is important part in industries. This is done for future analysis. In Fig. 13, the screenshot of energy meter logged data parameters in Excel format. In that, the 3-phase voltages, 3-phase currents, power factor, frequency and 3-phase powers recorded. We can check data in any particular date. For analysis purpose we did the data log. 3. Results. All the operations are controlled from the HMI, like speed control of induction motor using reverse forward control by using contactors, DAL starting of induction motor, and speed control using VFD through PLC analog output, system start, stop operations done from the HMI through PLC. Energy meter parameters are monitored like voltage, current and power on the HMI. Now this all the demo projects are ready for the practice and hands-on to the all upcoming students in the college, and helps them to the better understanding. This project gives the overview of industrial automations used in the industries. After implementing and practiced all above experiments, we are able to handle and introduce to the present industrial automation system. We found from above the automation can make the engineering is more efficient, less time-consuming, flexible, more useful, and interactive to the operation point of view. Also, it is more accurate and can act more safety and protective to the equipment, machinery, process. Hence, automation can be widely accepted in industries in its need for the economical productivity. A conclusion. In this project we implement the hardware as well as programming. We have deal with the following topics. 1. It shows that the control and IT both are used in automation systems to realize one or more of its functionalities, and also control technology is used for operation of the individual machines and equipment. IT is used for coordination, management and optimized operation of overall project. 2. It shows that automation increases the profitability in many different ways by decreasing the labor and material and also energy requirements. 3. By using these techniques we can improve the quality and productivity. Industrial automation improves the reliability of production, so that industries get the accuracy and precision automation using less energy resources. 4. By using the intelligent techniques in industrial automation, the production process done better human-friendly and reduce the complexity of machine. B. Future scope. The automation industry is facing new type of challenges like that information security management. The major part of the challenge comes from the diffusion of new ICT technology into the field. Solutions in the field show a strong trend of convergence towards common ICT solutions, especially to IP-based communication and de facto operating systems. This autonomic network concept can benefit the productivity of smart applications in smart environment. Investigate the new strategies to improve the security management in automation field. Future automation engineers will no longer be limited to the field of production. Many automation projects, for example, will be implemented within the so-called smart city. In transportation, buildings, and healthcare, future automation projects will have closer proximity to people's everyday lives. The engineer's expertise in automation will be applied in many non-traditional fields. These innovations will drastically change people's lives, adding convenience. The automation system will become an important foundation for the future construction and operation of intellectualized and automated societies. Acknowledgement. It give me immense pleasure to present paper on industrial automation using modern controls, monitoring, data logging and development of training facility in college. These words of acknowledgement are my gratitude towards people who helped me throughout and without them successful completion of dissertation and paper. I have been very fortunate to work with Professor Swapnil Namekar who has supervised the research carried out for my dissertation.